What's up, guys? It's Adam Bomb, and welcome to an episode of Universe Sandbox. Been waiting to try this game for a while. This is actually Universe Sandbox 2, so it looks a lot better than the first one. I don't know if you guys ever saw it, but I am a huge nerd, so this kind of stuff is what I like. I just wanted to announce to you guys that the stream for Minecraft is going to be this weekend, Saturday at 6 p.m. Pacific time. So hopefully you guys can be there, and hopefully I'll have a server going. Regardless, it should be a lot of fun, and I will give you guys more details as we get closer to the date. I kind of wanted to make this an informative video as well as a fun one, so I'm going to tell you guys some planetary facts while we blow up some planets and have some fun. So I don't know if you guys know, you probably do, that Mercury is the smallest planet in the solar system, and it only has an 88-day year. Alright guys, so we're going to pelt Mercury with some asteroids while I tell you some more facts about the planet. Wonder if it'll actually end up blowing up. We'll see. So I don't know if you guys know, but Mercury is only the second hottest planet in the solar system. Even though it's closest to the sun, Venus actually has a hotter surface temperature because of all the gas in its atmosphere. Alright guys, I'm going to put a moon around in orbit around Mercury. Oh, that is awesome. Oh my gosh. Alright, so if we put it really close, it just smashes into the planet. You can turn it into like a molten... Oh wow. Mercury's getting beat up, guys. So Mercury doesn't really have an atmosphere. It has a very thin atmosphere. Surprisingly, they didn't really do that much to it. Kind of surprised about that. Alright, let's go to Venus, guys. So as you can see, guys, Venus has a pretty nasty atmosphere. That's all sulfuric acid, nitrous compounds, really gross stuff. I don't know if this is interesting to you guys, but basically Venus has such a thick atmosphere that it traps in all the heat that comes from the sun. Basically, like, you guys hear about Earth having a greenhouse effect. Well, Venus has it like super hardcore. All right, guys, so I put some rings around Venus, which it obviously doesn't have. But Venus is actually really similar in size to Earth. It's only 81% of the mass, and it's only about 500 kilometers off the size of Earth. So they're basically the same size. It's just Venus had the unfortunate luck of being way closer to the sun than we are. So sorry, Venus. That sucks, man. Venus also rotates counterclockwise, which you can't really tell, but that doesn't matter. It's kind of an interesting fact. The Russians were actually the first country to visit Venus, and they put a lander down. Taking a trip to Venus is very hazardous, and they lost their probe. What probably happened is it touched down or got lost in the atmosphere and basically melted. The surface temperature of Venus is enough to melt lead and a few other metals, so not a very fun place to be. Let's send in some asteroids. Whoa, guys, we changed Venus's atmosphere. I threw in a few asteroids, and it kind of just vaporized its atmosphere. So now you can see what Venus's surface looks like without the gaseous stuff in the way. So as you can see, it's a very orange planet, kind of yellow sometimes, and it actually has a core, and it has a lot going on. I didn't know its poles had ice. That's interesting. So I guess we learn something new every day. Maybe that's not ice. Maybe it is something else, but that's pretty cool. Let's send another exoplanet into... Oh, that's huge. I don't want to send that one in there. Can I pick another one? Oh, God. We just blew up Venus, guys. Whoops. And there it goes. Yeah, this would majorly disrupt Earth. If we lost Venus from our orbit, Earth would be way closer to the sun, and it would just be bad news. So you guys might have heard about this planet. This is Earth. I have some cool facts that you guys might not know about Earth, actually. So Earth was actually made by the collision of a planet that was smaller than Earth is right now, collided with an exoplanet about the size of Mars. So I'm going to kind of run a simulation of what would happen if a planet collides with another planet and how big it would actually be after that. So this is what Earth looked like about a few billion years ago, and Earth is only the size it is today because of that collision with another exoplanet. So we are actually two planets in one, which is pretty fascinating. The moon is actually a leftover of the collision between this planet and Earth, and that is why we have our tides. The moon is very important to our survival. If we didn't have the tides, we would have a very interesting life. Probably wouldn't be good for us. You guys can probably see that after this collision, Earth is definitely not very even shaped. It looks kind of funky. Well, Earth as it is right now actually is not even shaped at all. It's kind of egg shaped in certain places. It kind of bulges around the center. So you might find that interesting. I think it's kind of cool to know that our planet's not perfect and it's had a lot of history before we got here. All right, so here we are at Mars, which is the fourth planet from the sun right after Earth. So I don't know if you guys know that Mars is actually a very small planet. Mars is only about 15% of the volume of Earth, which is pretty crazy. It's a very, very small planet compared to Earth. We've recently found out that Mars does have water. As you guys can see, it's got those polar caps, which have a little bit of water under there. And who knows, maybe there could be water underground. That is true of a lot of the rocky planets in our solar system. They could likely harbor oceans underneath them, which gives us the possibility of life, which I think is really cool. Mars only has 2 small moons, so I want to see what happens if we give Mars a big old moon. Let's give Mars our own moon, and I'm going to try and make it sort of realistic. Oh, I accidentally blew up Mars. All right, let's do it a little bit farther. There we go. Now we can kind of see it orbiting. Oh, that's sweet. It's got a really weird orbit right now. It's kind of... Don't crash into Mars. Is it still orbiting? I think so. Yeah, we managed to get it to orbit Mars. Sometimes if you send a moon into the orbit of a planet, it kind of will just slingshot it off into the abyss, which is how we get a lot of our... that's how we get a lot of our spacecraft from Earth to go a lot faster and farther. So that's sweet. Mars now has a big old moon, and it's on fire because I accidentally put a moon too close to it. Whoops, sorry, Mars. I was going to go show you guys Olympus Mons, which is the tallest mountain in the solar system, but unfortunately we blew it up. But now we get to see Mars is cooling down a little bit. Well, it's going to be a lot bigger now. Sorry, Mars. All right, guys, here we are at Jupiter, which is the 5th planet from the sun. As you can see, Jupiter looks pretty normal. And if you guys can notice, you probably can't, it's really hard to see, that dust storm, the red spot that you can usually see on Jupiter, is actually getting a lot smaller, and it may not be visible soon. All right, so I put some asteroids in orbit around Jupiter, and as you can see, they have like crazy orbits right now. A few of them hit the actual planet, but it's not the planet's surface because, as you guys probably know, this is a gas giant. There is actually a very small solid core on Jupiter, but the majority of the core is liquid hydrogen, which I thought was pretty cool. Let's put a random rocky planet in orbit. All right, hopefully that doesn't destroy it. So Jupiter is actually big enough to have a rocky planet orbit it, which is pretty cool. It's a very large planet. I can't remember exactly how much larger it is than Earth, but it's very, very large. Jupiter has the largest moon in the entire solar system, and that is Ganymede. I'm going to try and find it. Ganymede, Callisto, and Io, also Europa, I forgot to mention, are moons that actually have a pretty good chance for having life. They are big moons, which means they're bigger than some of the dwarf planets we have in the universe, and some of them have underground oceans, and others are pretty volcanically active and may be good candidates for a human colony. So that's pretty cool. Let's put Ganymede in orbit around the sucker, and there it goes really fast. Ganymede is actually bigger than Mercury, which makes it an insanely large moon. I mean, we have a moon that's larger than a planet in our solar system, so that's pretty crazy. All right, guys, here we are at the 6th planet from the sun. Let's put some rings around Saturn. This actually says Saturn, so now we can see this is roughly what they would look like, but they're not actually this big. The rings around Saturn are basically dust, so they're making it larger than it actually is. And you can only see the rings from Saturn with a high-powered telescope or on a really good night. They're definitely the largest rings in the solar system. Saturn is one of the flattest planets, which makes it so that the poles are actually pretty low compared to the equator. So it's kind of a squat sphere, I guess you could say, more like a vertically turned oval. All right, guys, here's one of Saturn's moons. It's Titan, which actually is another pretty good candidate for life, along with a lot of Saturn moons actually have oceans, frozen oceans, and could potentially be some of the best candidates for life in our solar system, but probably won't know for a long time. All right, so there is Titan. Titan's another really big planet, and let's try and zoom in on it. So Titan's about twice the size of our moon, and it's actually about a third of the radius of Earth. It's a huge planet. It has a kind of a rocky surface, but again, could potentially harbor underground oceans, which I think is really cool. Not quite lastly, we have Uranus, which is the butt of everyone's jokes, right? Am I right, guys? The butt of everyone's jokes? Ha, 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 ha. All right, I won't make any more jokes like that, guys. Uranus was actually the first planet discovered without a telescope. It was discovered using mathematical equations, which scientists suspected that Uranus was there because of fluctuations in the sun's brightness and in the gravitational pull of other planets. Whoa, I just made a ton of fragments by impacting an asteroid with Uranus. Oh, sweet. That's really cool. Every time I do that, it makes a ton of fragments. So what's basically happening is that the asteroids are hitting Uranus's atmosphere, which is really icy. Uranus is considered an ice giant rather than a gas giant, just like Neptune. So they are gassy, but mostly the atmosphere is made up with frozen gases and looks very blue to us because of the refraction of light off of these. All right, guys, we're at the last planet of the solar system, which is Neptune. I know, unfortunately, it's not Pluto. Pluto is a poor little dwarf planet, which we'll get to in a second. Don't worry. But Neptune is now technically the last planet in the solar system. Neptune actually has 14 moons, and one of them is very interesting. That would be Triton. And Triton is a very icy planet, but contains methane, frozen methane, and potentially water lakes under the frozen surface. So the reason I mention all these water-bearing moons and planets is because of their potential to either already have life, which is probably unlikely, or to be able to host humans, which would be pretty cool if we wanted colonies in the future. So unfortunately, they don't have any of Neptune's moon in the system, so we're just going to throw a moon real nice and close to it and see what happens. See how close we can get. Oh, that was so sweet. Let's do that again, guys. These moons are actually so small compared to Neptune that they just make a big impact, and it looks sweet. Let's see how many we can do before it just starts to screw up. Oh man, that looks so sick. So Neptune has a really crazy atmosphere. The winds are the fastest in the solar system, and they almost, I don't know if this is true. I remember hearing this, that the winds move faster than the actual rotation of the planet. So I don't know if that's true, but the winds and storms on Neptune are definitely the craziest in the solar system. It would be extremely hard to get any kind of spacecraft into its atmosphere. So I thought something would be interesting to show you guys here. Here is Neptune and here is Pluto right here. And the reason this is interesting is because Pluto's orbit actually intersects Neptune at some point. And so at one point in their orbits, Pluto is actually closer to the sun than Neptune is. They're just both so far out, which is, it's like the scale is hard to imagine. It's crazy. Oh, this is awesome, guys. They have the updated, it looks like the updated, they updated the model of Pluto after they did the New Horizons flyby, which just happened I think that was a few weeks ago. So pretty cool that they updated the model of Pluto. So they actually included one of Pluto's sort of moons. And I say sort of moon because look at the comparison in size between Pluto and its moon, Charon. I don't know if they even consider Charon a moon of Pluto or not because they're basically binary dwarf planets. Charon is, I think, about half the diameter of Pluto. So let's put it in orbit. Let's speed it up to see if this orbit is actually stable. If it is, I think I got it pretty much as close as I can without it actually hitting the planet, which is pretty cool. All right, guys, since we just went to Pluto, I wanted to load the simulation of New Horizons passing by Pluto. Here you can see all its mini moons, and there's Charon, which is huge as heck. Oh, sweet. All right, so you can see the direction it took past Pluto, and there we go, past all its moons and everything. And here is the spacecraft itself, which is a replica of what it would look like. And this spacecraft is just going to keep going way out to the solar system past the Oort cloud, which is this big kind of other asteroid belt that our solar system has. And it's kind of right at the boundaries of where our solar system stops and ends. It's just going to keep going and going. Anyways, I hope you guys really enjoyed this episode. I didn't do any stars or galaxies in this episode. That will be in the next episode. So if you guys enjoyed hearing facts while I talk about this episode, please let me know. Otherwise, I will. And if you didn't, please let me know if you would rather see more simulations and things exploding, which is always nice. And maybe I can do both. So you guys let me know. Thank you for watching this episode of Universe Sandbox. And please leave a like or a comment if you enjoyed this.